So question number 5, the molecule in the material may possess the kinetic energy Ek and the potential energy Ep. The internal energy is basically a sum of all the kinetic and potential energy of the molecule. So submission sign, so sum of the kinetic energy plus sum of the potential energy of the molecule refers to internal. How we represent a sum? That is sigma and kinetic energy Ek plus sum is denoted by sigma and potential energy is Ep. So C should be the right answer for this. So in this question, we have a mixture of helium and hydrogen which are maintained at 300 Kelvin. So if they are maintained at 300 Kelvin, it means they have the same temperature. Whenever temperature is same, it means they will have the same kinetic energy. And if two different particles have the same kinetic energy, because the helium mass is more, so as the helium mass is more, so it means its particle will move slower. And for hydrogen, its mass is small, so its particle will move faster, but the half mv square for helium will be same as half mv square for the value of half mv square, the kinetic energy for helium will be same as for hydrogen. So when we check the statement, which of the following is correct? The average kinetic energy of the helium molecule is greater. That is wrong, because they should have the same kinetic energy as they are maintained at a constant temperature of 300 Kelvin. The average kinetic energy of helium molecule is same as average kinetic energy of hydrogen molecule. That is true. The average speed of helium molecule, not about speed. As you can see, helium molecules are heavy. They are moving slower. And average speed of helium molecule is same. Again, it is not same because their mass is different. So their speeds cannot be same. Otherwise, if their speeds are same and they have a different mass, then they should have a different temperature as well, because the result of kinetic energy, which is half mv square, will come out different for hydrogen and helium. So a student carries out an experiment to measure the specific heat capacity of a block of aluminium by heating the block with electric heater. The value obtained by the student is less than the textbook value. So specific heat capacity is equals to energy divided by mass into temperature change. So it means if student like provide more energy, then specific heat value will be higher. But if it's less amount of energy is supplied, it means the specific heat value will be, because the student value is less than the textbook value. Or if he measure like there's a greater change in temperature, he will get a smaller value. Or if mass is overestimated, like if the mass of the block is more, then the value of a specific heat capacity will be smaller. So these are the three factors which can reduce the value for specific heat capacity. The heater is inefficient. If heater is inefficient, because how we supply heat energy, we use electrical heater. The energy supplied by the heater is power into time divided by m into delta T. So if the heater, or delta theta we can also say, if heater is inefficient, it means it will work for a longer period of a time. So if the time increases, then the specific heat value capacity should increase. But when the mass is overestimated, like more mass is measured as compared to what is, or estimation of the mass is like estimated higher value, then the specific heat capacity will be lower. Thermometer scale did not start from zero. If the thermometer scale did not start from zero, like that does not have much difference, because we want to measure a temperature change. Even thermometer start from zero or does not start from zero, does not make difference to the experiment. The thermal energy transfer to the surrounding. If thermal energy transfer to the surrounding, so again we have to heat for a longer period of a time, or greater amount of energy is needed to increase the temperature. So that will also give a higher value of specific heat capacity. So B is the right answer, that the mass of a block is overestimated, which will leads to a smaller value of specific heat capacity. The kinetic energy is half mv square. which is proportional to temperature, or 3 by 2 kT. So in the question, the mean square speed of a gas molecule is double, means this whole value is double. If they say root mean square value is double, then mean square speed will be 4 times. But the whole factor v square is double, like it, so it means it become 2v square. So what will happen to temperature? The temperature should also be double, so temperature will become 2T, so it will increase by factor 2. If only root mean square speed is double, then the temperature will increase by factor 4. In this question, an ideal gas is maintained at a constant temperature, so temperature is not changing. In a sealed container, the volume of the container is varied. Which of the following is a correct statement about the pressure exerted by the gas? So, if the temperature is constant, it means we have to apply a Boyle's law. And according to Boyle's law, pressure and volume are inversely proportional at constant temperature. So, pressure is directly proportional to volume, that's wrong. Pressure is independent of volume, that's also wrong. Pressure is inversely proportional to volume, so C is the right answer. And pressure proportional to square of the volume, that is totally wrong. So if the temperature is constant, if we maintain a constant temperature, the pressure exerted by the gas is inversely proportional to the space occupied by the gas molecules. So it will follow the Boyle's law, that's why C is the right answer. In this question, a gas consists of a molecule of nitrogen. So nitrogen is N2 and the total mass 14 multiplied by 2, 28 AMU, and oxygen is O2 16 times 2, so 32 AMU. The oxygen molecule are more massive, means they have more mass than the nitrogen. Which of the following statement is correct? On average, all the molecules have the same speed. This can never be true because even the molecules cannot have same speed. They are moving with different because a gas consists of a nitrogen and oxygen molecule. So if they will have the same temperature. When a container is there, in the container you will have the same temperature, like example 300 Kelvin. An oxygen molecule and nitrogen molecule both are present. Oxygen molecule will have the same kinetic energy as nitrogen molecule because the temperature of a gas inside the container will be same. So their kinetic energies will be same, but the speeds will be different because oxygen is having a greater mass, so its molecule will move slower. When nitrogen is having a small mass, so its molecule will move faster. So on average, all molecules have the same speed, so they cannot have the same speed. On average, all molecule will have the same kinetic energy. So all the molecule will move with the same energy, or they will have the same kinetic energy. So B will be the right answer. Why not C or D? On average, the nitrogen molecule have more kinetic energy. They cannot have more kinetic energy because they're in the same container. So they should have this, the container will have the same temperature throughout. That's why they will have the same kinetic energy. And on average, speed of nitrogen molecule is less. That's wrong again. The speed of the nitrogen molecules is more. Why it is more? Because the nitrogen molecules are lighter. As the molecules are lighter, they will move faster. So D is also incorrect. The correct option is B. So in this question, relative masses of oxygen and hydrogen are 32 and 2 because oxygen is O2. So 16 times 2 and hydrogen is H2, which is 1 multiplied by 2. For any given temperature, so if the temperature, the root mean square speed of oxygen molecule compared with the root mean square speed of hydrogen is given. So the ratio of their root mean square speed. So, or basically we can also say V, because like V square is a known as the mean square speed, and if we take under root, so it is known as the root mean square speed. Because at a given temperature, so it means they will have the same kinetic energy. So we can say kinetic energy of oxygen, the kinetic energy of O2 will be same as the kinetic energy of H2. Then kinetic energy is half mv square, so it will be half. The mass of oxygen is 32, that is given in the question. And example speed, we are saying v square, that is O2 for oxygen. And half the mass of the hydrogen is 2, and the speed is example h2 square. Then we simplify this, half will cancel with half, this 1 by 2 cancel with 1 by 2. Then we cross multiply, so it will be average speed square, or squared mean speed of oxygen divided by square mean speed of hydrogen is equals to 2 by 32, or we can also say 1 by 16, because 2 by 32 will be simplified as 1 by 16. So this will be 1 by 16. But in the question, root mean square speed means we need only the ratio of oxygen molecule speed divided by ratio of hydrogen molecule speed, and in a root, or the value of the v. So if we want, so we'll take a root here. So when we take under root both sides, so this will come out v square, like speed of oxygen, which is a root mean square speed here, divided by speed of hydrogen. Their square will cancel with the root, and that is under root 1 is 1 and under root 16 is 4. So it will be 1 by 4. So B should be the right answer for this question. The average kinetic energy of the molecule is proportional to what? So kinetic energy is proportional to temperature of the gas, or we can say kinetic energy is half mv square. So this is squared speed proportional to temperature, which is also we can say 3 by 2 kT, or equal to 3 by 2 kT. So it's not the number of the molecules, that's wrong. Specific heat capacity of a gas, specific heat capacity and temperature are, because we have the formula C is equals to E divided by m delta T. If it's a temperature increases, so specific heat capacity will be lower. Like higher change in temperature, lower specific heat capacity. So not directly temperature of the gas, that's true, because if higher specific, like if the temperature kinetic energy is higher, it means the particles are moving faster, or we can also say that the temperature of the gas will be higher.